Okay, 111, we're going to finish off this graphing calculator activity by working through number 9. So we are given the formula for the surface area of a cone. It's S equals pi r times the square root of r squared plus h squared. And it says we are given a surface area for a tank, which is 200 square meters, and its base radius is 5 meters. And it asks what the height is. So in part A, what we want to do is solve this algebraically. So let's let the surface area, S, be 200. And let's replace all the r's by the number 5. So pi times 5, square root, 5 squared is 25, plus h squared. Okay? So now they ask us in part A to algebraically solve for h, right? Figure out what the height would be if we know the surface area and the radius. Okay, so first we got to divide both sides by this pi times 5 that's right here to get the radical isolated. Then we can worry about the radical. So divide both sides by 5 pi. And over here, it looks like I get 40 over pi is equal to square root 25 plus h squared. Now, to get rid of the radical, I square both sides. And then I can subtract 25 to get the h squared all by itself. And I can work out this square also, by the way. That's 1600 over pi squared minus 25 equals h squared. And to get the h by itself, I just have to use the square root. So I get h is equal to, usually we would do plus or minus, but because h is a height, the minus doesn't make any sense. So I get square root of 1600 over pi squared minus 25. And you can, this is just a number, by the way. This stuff on the left side, that's all just a number. So you can plug that into your calculator and get an idea of what that is as a decimal. But let's see how to handle this in part B. Okay, and by the way, the units for that would be meters. For part B, we want to solve this graphically because the algebra on that was kind of yucky, right? Okay, so doing this graphically would be thinking about this equation that we started out with, this 5 pi, or 200 equals 5 pi square root 25 plus h squared. If I sort of take this apart and think about how we've done this in section 1.3, I believe it was, I can say I'm really looking for where two equations equal each other in the xy axis, right? So I'm looking for where, for example, y1 is 200 and y2 is the right side, 5 pi square root 25 plus h squared. I'm really looking for where these two equations equal each other. Right? Where these two equations equal each other, that gives me the above equation. So if I graph each of these two things and then figure out where their intersection point is, then I've solved the first equation. Okay, so let's go ahead and clear out our circles from before. Let's enter y equals 200 and then y equals 5 pi. The pi button is above your exponent key right here, above your little caret right here. 5 pi square root, you don't have to put a times if you don't want to, 25 plus, now we don't have to use the letter h, but we can use x, right? It's just asking for what the input is, right? Squared, okay? Now, notice y equals 200 is going to be like way off of our screen, right? We're not going to see much when we do this, okay? So we're going to need to change our window a bit, right? So we can go to window, and x max being negative doesn't make any sense, so let's change that to 0. X max, I don't know, let's try 50. And if this is awful, we'll try something else. Y min, let's not make it negative, let's start at 0. Y max, well, if this is at 200, we better do something big, so how about like 300? Okay, let's hit graph and see what we get. Oh, there's y equals 200, and there's the other thing, right? Okay, and so now what we're looking for is that intersection point right there. So let's use second calc, and let's use intersect. Enter. Again, intersect works by just highlighting or floating over where you think the intersection is. It looks good. Close enough. It looks good. Enter. Guess. Aha! Our intersection happens at the ordered pair approximately 11.71, 200. Okay, so what that means is this right here is our value for h, right? H is approximately, we should use squiggles, 11.71 meters. Good, and I think from part A, if you work that out in your calculator, that would be about what you got. Good. All right, that finishes out our graphing calculator activity.